We have already covered these things. Today we'll configure multiple wide IP with single listener. Configure multiple wide IP single listener. What is the meaning? Configure wide IP with single listener. So listener, I already mentioned listener is a VIP IP, virtual IP. So that will act as a DNS server for the user. So for example, I am the user. Or for example, in this lab, this is the user. So for this user, listener IP is acting as a DNS server IP address. So what we'll do, we can use single listener IP like from this range IP 192.168.127, and instead of wide IP, single wide IP, we can create two wide IP. Wide IP means FQDN. FQDN means the actual application which is hosted behind our load balancer. That is this LTM1 and LTM2 boxes. So let me take the pen so that I can explain in very good way. Okay, so we'll use same listener IP from this range 1.127. This will be acting as a DNS server for these machines. And in wide IP, let me delete this. This is useless. Okay, so in wide IP, we'll create two wide IP. One is www.example.com. And inside this wide IP pool, we will call this LTM box VIP IP. See, if any user, this user, to try to hit this application, HTTP www.example.com, this user will get this IP address. And now he will start communicating with this IP address. Now this backend, this F5 DNS, F5 LTM will send the traffic to this server, and again traffic will handle like that as per the normal load balancing method. So DNS comes in the picture only to provide the IP address. And once user get the IP address, now user will start communicating with this IP address with the backend server as per the load balancing methods. In short, I can tell this application is hosted on this application server. And DNS entry, for DNS entry, we have made VIP on the LTM boxes. So that is an LTM is acting here as a full proxy, reverse proxy. People coming from internet to access application, that is called reverse. People from inside to go into the internet, and if any device coming here for the proxy purpose, that is called forward proxy. So there are two types of proxy. Okay, and in second wide IP, we'll give another FQDN, for example, www.abc.com. So if any people, or just consider this user, is trying to hit www.abc.com, this time F5 DNS will give IP address of this LTM box VIP IP, whatever you configure. So when creating wide IP for this application, FQDN will call in a pool this IP. And for www.example.com, we will call in pool this VIP IP. So we are using single listener, but with the help of single listener, this user can access multiple websites. One of website is hosted on the India data center, and one application is hosted on the US data center. So if any user trying to hit, he can access two applications from the DNS IP address, that is listener IP address. So this is our agenda. This is called configuring, multiple wide IP with the help of single listener IP. I was forget to start this thing. It will take like 3-4 minutes. So it should be a start in the beginning itself. No problem. So this is the concept of configuring multiple wide IP with single listeners. If you know these things, wide IP and other stuff, we can easily handle the DNS things in your productions. So in my current company setup, we have the same things. We have GSLB setup, not other setup. So they have very big infra. Now then we can see configure DNSSEC in GTM DNS with zone signing in key signing key. So what is DNSSEC? So before us, because our system is starting, so meanwhile we can see the DNSSEC theory part, and we can understand what is DNSSEC basically. So F5 DNS and okay, you should open this in the um, actually I have already made from my from you can say like DNSSEC concept. So this part is made by myself itself. I did not copy paste or snapshot taken from anyone. This is made by me itself. And this I have taken from some years. That's for the understanding purpose, so that I can explain to you guys the DNS. We can open these and save in the PDF format. Okay, so DNSSEC is domain name system security extension, we can say, or maybe I can show here. So let's see a little bit theory here, and then we can. So DNSSEC is domain name system security extension, we can say. So by default, DNS has no any security. DNS has no any security from a compromise perspective, like attack perspective. So DNS and there is no any security. But with the help of DNSSEC, we can DNSSEC basically sign the record. With the help of DNSSEC, we can sign the record like a record. And if signature is matching from top to bottoms, like um, uh, how DNS work, you already know. Like for example, we have this PC and this user, and we have local DNS here, local DNS server. This request go to the root server, then TLD top level domain server, then authoritative DNS server. Authoritative DNS server in our case, let's consider F5 DNS. Who had the actual IP address of the applications. So if the query go for examples, you are requesting for www.example.com. I need IP address of www.example.com. Query come to the local DNS. Local DNS had not the record of www.example.com. Local DNS will send the query to the root server. Root server said, okay, I don't know IP, but I know we need to go to the .com. It will send to this. Then it will send, okay, I don't have IP address, but we need to go to the name server, authority name server. Then LDNS will send the request to the authority F5 DNS server. Then F5 DNS server will provide the IP address to this local DNS server. Local DNS server will maintain its cache and provide to the user. Now user will start communicating with that IP address. Let's consider instead of the actual authoritative server, maybe some bad guys here, and instead of the actual IP address, maybe someone provide wrong IP address to this local DNS. A local DNS will provide the user. So now user will start communicating with the bad IP, because communication always happen with the help of IP address, not the FQD. So when user will start communicating with the bad IP address, it is wrong thing, like everything is get compromised. So instead of actual application, we are communicating with wrong applications, some malicious applications. So for that purpose, DNSSEC comes in the picture. How it will work, how it generally work, we'll see in some times. So this is the basic concept, like with the help of DNSSEC, actually this is the basic concept. And we can say like this is how DNS get compromised, like poisoning attacks and some wrong IP address. Uh, how we can avoid it, we'll see in some times. So let me please. Let's see some part from here also. So DNSSEC main focus to prevent DNS catching poisoning, name chaining, PKI chain of trust at each layer of the DNS architecture, public private key. DNSSEC related to license, it is optional. We don't need to take additional license for this. 3 F5 DNS modes like delegation, authoritative, a screening mode, DNS load balancing. This is not a part of DNSSEC. So, like for example, we use delegation concept here, authoritative, a screening mode. So this is just for the concept. Don't get confused here. We'll see while doing the lab. DNS load balancing. So this is we use everywhere at the times of when we do the configuration GSLV. So we generally use the load balancing method. Yeah. So this is how DNSSEC works. So this is the example. Let me explain this so that configuration is only 5 minutes work. We need to just understand the concept here.
Okay.
It is, see, in DNSSEC, there are some two types of key we need to create. So DNSSEC long form is domain name system security extension I mentioned. There are two types of key we need to create on the F5 DNS server. That is key signing key. Basically, it is a public key, long-term public key. And second one is zone signing key. So key signing key is basically the public key, and it is a long-term public key. And this key is used to sign the zone signing key. Okay. So key signing key we use to sign the zone signing key, and zone signing key sign the record. For example, our F5 DNS has a record. www.example.com is binded with 192.168.170.5 example. So this will provide this record to the user, to the local DNS. Apart from it is going to be signed this with the help of key, with the help of public key. It is going to be signed it. Okay. So whatever things we have signed through our public key or private key, that will be only decrypted through the, we can select opposite one. If you are doing anything through public, it is going to be decrypted through private. If you are doing anything through private, it is going to be decrypted through the public. So this is the meaning of two key signing key, zone signing. Key signing key is a public key, and with the help of that public key, we can sign the record. Okay. And this is the delegation signer record. So delegation signer record matlab, when you are creating zone signing key, or maybe say when we create zone for in our lab in sometimes www.example.com, it is automatically going to create the DS record. DS record means hash value of the public IP, hash value of the public IP, and this hash value we need to upload here on our registrar that is GoDaddy. For example, this domain www.example.com we have buy from the GoDaddy. This is a common thing, right? We need to buy the domain from the provider. We can't publicly access any application, any domain. We need to buy your domain from the provider, registrar. In our case, we can take example of GoDaddy. So this hash value of the public key should be uploaded here, because when local DNS will send query to the root server will give the IP address including this hash value. This request again go to the .com. .com will send the IP address with hash value, and both hash values should be same, because this is uploading. We are uploading on the top root level server, and if you are uploading on the top, it should be come to .com and other place also. Okay, when a local DNS will send the request to the authoritative DNS server, let's consider F5 DNS server. It will give the same key, and local DNS server is going to verify, okay, whatever hashing value we are getting from root, same from .com, top level DNS server, and same from the authoritative DNS server. Means whatever communication we are doing, that is the genuine person. like root server is also genuine, top level.com is top level domain is also genuine, and our authoritative name server is also genuine. So this is how establish the chain of trust in between our query from local DNS to till root, top level, and authoritative. So that is the only thing. This is the functionality of the DNSSEC. So for that purpose, DNSSEC comes in the picture. And this is called RR, resource record signature of DNSSEC. So for example, we have multiple record created on the F5 DNS, like 1, 2, 3. So if you are grouping together and sign it, that is called resource record signature. So this is the basic functionality of DNSSEC. So if anyone asks what is DNSSEC, we can tell DNSSEC sign the record. We can sign the record. DNSSEC provide DNSSEC has the capability to protect any DNS poisoning, anything related to modification in the middle related to DNS, because it establishes a trust, chain of trust from the root to top level domain server to authoritative name server with the help of the key, with the help of the public key that is called hash value of the public key. And that key is going to be checked against all the query. And if any key is mismatched, for example, root server is applying to local DNS server, let's give the hash value public key of hash value of public key. When .com server will send, it has a different things, not the same hash value of the public key. Means it can understand and query will be not resolved. That query will be not resolved. Like user will not, local DNS will not get the IP address of the any applications. But in case of normal DNS, this feature is not available and it get compromised, it get wrong IP address also. So that is the functionality of DNS.
Yes, bhai. So got some clarity, but can you repeat this again? Like,
Yes. Let me
please.
it again.
Yeah, thanks.
Okay, so here our F5 DNS is acting as an authoritative DNS server for the domain.com. So this domain.com, we have taken this domain from the registrar go.adages, for example.
Yes.
So in F5 DNS, we need to create two key signing key and zone signing key. And then we need to create DNSSEC zone. In inside zone, we need to mention this domain. www or for example, domain.com. And when creating the DNSSEC zone, at that times, this record is automatically get created. DS record. DS record is the hash value of the public IP. Sorry, public key. Hash we know very well, right? For example, this is the key and you are using SHA-255, for example, or MD5 and generate some hash here, 1, 2, 3, 4. That things we need to come to the restart GoDaddy and we need to upload that hash value of the public key for this domain.
Yes.
So when anyone do query, putting the hash value of this public key. This request again go to the .com. It will give the authoritative DNS server details, including the hash value. Same value should be there here. Then this is going to be send this query to the authoritative DNS server. That is our F5 DNS, where already this detail is there. So it is going to be verify against that. And then if it is coming from the good, it is establishing chain of trust, then this is going to be provide the IP address, whatever it has the record to the local DNS provide the user will start communicating with the IP address. So it is kind of, establishing the chain of trust, like whatever communication we are doing with the genuine people. Okay, so that is the only things happen with the help of DNSSEC. First time we can't understand easily, and we don't need to go deep dive because it is not much required to go in deep dive. Just we need to understand the concept also and how we can configure the only things we need to understand.
Okay. So in short, the hash value should be matched. Is it like that? Can we say
Which one?
hash value should be matched in every case, like from root server, from the authoritative server as well? Can we say like that, or while getting the IP?
Yes, correct. So let me explain again. Explain like that. So this is our normal DNS functionality. This one, pipe, DNS. For this example, let's understand here. Yeah. So here we'll get okay. So this is the local. So this is the we can say like I think yeah. This is the computer we can say, and it is trying for f5.com recursive query. Look f5.com. It will go to the local DNS server, cache the IP address. That is the different thing. Local DNS server will send this request to a
Root server.
root server. Okay, so root server, when root server will, or I can explain this way. Just 1 minute. I'm trying to do my best so that we can understand the concept. Yeah, here it will be simple and so. See, so this is the just consider this a root server.
Yes.
Sign record including just consider we have the domain mybank.dom, mybank.dom. So when root server is replying, it is going to sign the record including this .dom public key also, public key of .dom. So when this query will send to the local DNS, local DNS has the detail. Okay, in this time I need to reach to .dom, and I know the .dom public IP because it is given from root server. Okay,
Yeah.
just understand like that. When the local DNS will send query to .dom will provide the public key of mybank.dom. This is hosted configure on the F5 DNS, just for example. So when local DNS server will do query to the F5 that mybank.dom, local DNS server already know because local DNS server has already get details public key of the this mybank.com, mybank.dom. So if this user will respond with IP address, and if this key not matching public key of mybank.com, then local DNS understand, okay, no, this is something wrong. This is not coming from good people. So these types of trust build with the help of DNSSEC. So that is the functionality of DNS.
Okay.
Okay. So whatever root server is giving, it is giving with next people public IP also. Okay. Signed records including .dom public key for .dom. Okay. Same thing coming from top to bottom. Okay.
Yes.
So this is the functionality of DNS. So now if we come here, mic.com sign key signed record for www.mybank.com because now local DNS server already understand, okay, I know what is the key public key for mybank.com, and same people I'm getting the request, and that is signed sign the record of www.mybank.dom. So now it will maintain its entry in local DNS cache and send to the user, and user will start communicating with that IP address. So it is just establishing the trust. Okay. So this is the mechanism of F5 DNS. Okay. DNSSEC.
Clear.
So okay, so this is about DNSSEC. So now let's implement both things in the lab, and that will be our. And for DNS troubleshootings, if we got time today, that is fine. Otherwise, maybe I will take one session maybe next week just for the DNS troubleshootings, and we'll complete that. So first we'll focus here. So let's access these devices here, and it only will access our DNS box here. Uh, so we need to come here on DNS listener. So we have already created one listener IP 192.1.127. So what we'll do, if we come GSLV and come to the wide IP, we have created this IP. This is green. What we'll do, we'll come here, and if we come in the pool, we have called two pool here. DNS pool. In DNS pool, we have two member is there. So what will member is two is there. So what I will do, I will remove one member. Let's remove this from here. I'm just removing from here. Yes. So one I have removed from this member. This pool in wide IP, we have called pool. Inside pool, we have two VIP. One from India
Yes.
data center, another previous data center. I have removed. So
Yes.
at the times, if you are accessing www.example.com, will only get this IP address 1.175.
Correct.
1.175. And now we'll create another wide IP here. Come here, wide IP. We can create here, and we can give name www.abc.com, and we can use as a record a record, and here we can round robin, and in pool we can select DNS pool. Okay, so inside DNS pool we have only one member is there. Okay. Okay, so better to do like that. First, let's create one pool here for the IP which we have removed it. So this is DNS pool where 175 is there. Ignore this, create another pool here. Let's create, for example, DNS pool test one. This is also a record. And because this is the pool, and pool inside pool we have the VIP, so we can use HTTP monitor. And here we can select, instead of 175, we can select 176, because 175 already call on another for the www.example.com FQDN. So we
Yes.
can add here and we can finish it. So we have created DNS pool 1. Now we need to create here wide IP here, wide IP. And we can create wide IP here, and we can give like www.abc.com, type A, type here, and inside pool we can select set a second one, DNS pool 1, and we can add it. We can finish. See, now it is green. Let me check the, we have used the monitor also, or we forget it. But anyway, it is green.
Yeah, inside pool we have monitor.
Yeah.
HTTP.
Yeah. Okay, so now if we see here, GSLB in wide IP, we have two wide IP, www.abc.com, www.example.com. If anyone try to hit say www.abc.com, it will give 176 IP address. If anyone try to hit www.example.com, it will hit the second IP address. But in DNS IP, it will be the same. We are not changing any DNS IP. Listener IP is the same. If you come here, if you access this box, this is the Linux box, Linux. If you access this, Okay, we can, what we'll do, we can stop it and then we can start. Meanwhile, we can take the step how we can configure DNSSEC. So configuring DNSSEC is very simple. First, we need to create both key signing key and zone signing key. Then we need to create DNSSEC zone with the FQDN. Then assign the zone signing key to that FQDN. And then we need to verify it. So first we'll create here. How we can create it? We need to go on the DNS delivery keys and DNS key list, and we need to create it. So DNS delivery keys. So if it is starting, meanwhile, we can follow this one. If we come here, DNS delivery and keys and DNS key list. So here, two keys already created, but I'm deleting it so that I can show you. Let's create here. So we need to create the key. If we type zone signing key signing key. So we need to create one zone signing key and key signing. Key signing key basically is a public key, long-term public key, and zone signing key is to sign the record in short I can tell. So key signing key is the long-term public key. Zone signing key is signed by this public key. Okay, and zone signing key sign the record, like whatever record we created for like example www.abc.com. Okay. So let's first create key signing key. We can give name here. We can give here like example.com _ this is key signing key. So we can give key signing, right? And these things generally change. So generally it is not required to change in the here lab environment, but company try to discuss these things with the F5 vendor first time. Like because after the time it is going to be expired for expiration period, here is 0, but we can mention here when it is going to be expired, this key. So generally we keep for the 1 year.
Okay.
And rollover period. So these are the things like after this time we need to create again the key after this 365. Okay. So this setting generally we need to discuss it. And bit late is fine, and we can just finish it. Key signing key is created. Now we need to create the zone signing key also. We can give www.example.com and instead we can give like zone signing key. And 185, 365 like 1 year almost, and we can finish it. So two key we have created. Meaning we already know, like what is the meaning of key signing key, zone signing key. Now we need to come to DNS and keys, GSLB zone, DNSSEC zone list. Here we need to create the zone. We can give in our environment, we have two zones. We have two domain, right? www.abc.com, www.example.com. So we can give full FQDN, www.example.com, and here we can attach zone signing key, here attach key signing key, and we can finish it. And we can create, see now it is green. Now we can create another one. www.abc.com. We can give here zone signing key.
These are for example.com. So that will be valid, right? For ABC. Okay.
Yes. Key is valid for both the FQDN.
Okay.
So like whatever record we are creating here, whatever the domain we have, that will be valid for all.
Okay.
And multiple name server is going to be combined. That is called resource record signature. So if you are combining multiple your record, for example, we have www.abc.com, we have www.example.com, we have www.123.com, for example. So if you are combining all at one place, that is called resource record.
Yes.
And if you are signing that with teacher signature, that is called resource record signature.
Yes.
We finish it. So now it is also green. Now coming to here, now access this Kali Linux. Now it is open. Kali. Okay. So if we come to the terminal here, first we'll test our first lab, whatever we will put the single listener, multiple wide IP. First things. So we'll hit www.abc.com and we will hit www.example.com. HTTP, because we are not using certificate and stuff, so we are not using HTTP here. So we can use here HTTP www.abc.com. See, I'm able to access the server, and it will give the EVS server number 3, that is EVS data center IP address, EVS data center application server, you can say.
Yeah.
And if we hit here HTTP www.example.com, see, I'm getting server 1, means India data center application server.
Yeah.
So we are using single listener but accessing both applications.
Yes.
Now we have tested first lab. Now come to our terminal here. I think it is already open. Or we can open from here. If we try to do here like D www.example.com, and we are asking the detail from 192.168.1.127 or listener IP. See, he is giving the IP address of 1.175.
175.
If you run the same command, but change the here instead of example.com,
ABC.
yeah, it will give 176.
Yes.
Right? And how we can show like our record signature and all related to DNSSEC. So we can use same command, plus we need to use here DNSSEC. So see, we have, let me just increase the size. See, we have 2 record on our F5 DNS.
Yes.
One is, see, this is the A record where the IP address is there. www.abc.com is binded with 192.161.176. And second one is resource record signature. So this is the signatures. So this record is signed by, we can say like, for this record, this is the signature. So when user is getting IP address, including this signature details also. So if anyone in middle trying to do modification and all, this is going to validate against their signatures. And if anything wrong from top level to till authoritative DNS server, the user will not get the IP address. It will get request timeout or something else.
Yeah.
So this record is signed by RR Signis resource record signature. So if you're signing this record with the public key or zone signing key, that is called resource record signature. The digital signature. Digital signature means like whatever we are signing the record and doing its hash value and share with anywhere in simple and so. Okay. So if you do the same for another domain also, example.com, and if you do plus DNSSEC, it will work. See. So If you don't get much clarity, just copy these. If you want more
Yeah.
clarity than that, if you are able to copy, if you want more explanation, just copy these, come to Copilot, which I follow sometimes. Come to this Copilot, paste it here. Oh, you're not paste. Okay, we can't paste it.
Yeah. I think you have to get a putty access.
Mhm. So, putty access of Kali Linux. Let's try that. Let's try that. What is the IP address of this? Okay, it's in this range, so we can't take.
1.101.
It should be in the range of you know
Uh,
192, 168, 127. Like our management subnet range, it should be our
management
management
software.
subnet. So what we can do, we can run the same command from F5 also. So let me access F5 DNS 192.168.137.108. This is our F5 DNS.
Okay.
because the because F5 has two mode, right? Two operating system. One
Yes.
is TMOS and one is
Bash.
BAS. BAT is basically Linux shell.
Yeah.
Okay. We are putting wrong username password here. Root. So this is the bash shell. If you run here dig www.abc.com plus okay, and we are asking this detail from the listener 192.168.1.127, and we can do here plus DNS stick. See,
Mm.
we are getting from here also. Just copy this, come to here, paste it, and just mention please. Oh, okay, please explain above results in details.
Mm.
See, so what is saying? Dig is the DNS tool. This is the domain you are securing. Target DNS server likely your threative. DNSSEC enable server. Request DNSSEC related record like resource record signature, DNS key. This is the header sections. The query was successful. QR means this is the response. AA means authoritative answer from the zone owner. RD means recursive desired, but your server does not support recursion as expected for authoritative only setups. The client asks for recursion, but the server don't offer it. This is normal for authoritative only server. And yeah, let's try to understand this one. Area code algorithm signatures. Okay, explaining signatures. Signature is basically base 64 encoded cryptographic signature. So base 64 means that is encoded.
Yeah.
So the presence of resource record signature prove the zone is signed. So whatever zone we are using, for example, www.bc.com, example.com, that is signed. Okay. No recursion direct from your DNSSEC related server. Common सी बात है यहाँ पर. We are not uploading any public hash value
Yes.
to the registrar and all. We are doing locally things. We can teach learners how to verify the resource root signature using DNSKEY and DS report. So this is a basic thing. So
Yeah.
in about the DNS6. Perfect. So now we have some time. So let's finish some part of troubleshooting also so that we can totally finish it. So if we come here, which types of troubleshooting we need to do in case of DNS sec, not only DNS sec, in DNS. So first things is always things to verify your certificate. Sometimes what happened, our device certificate got expired and we start getting some error. We start getting some like DNS server is not working, or people are not getting IP address. People
Hmm.
are not getting IP address. So first party device certificate are missing, expired, or contain duplicate common name. Entries with the certificate one of the synchronization group members. The system will be marked offline. And sometimes capital also we need to, I think we have, if you observe, we have like renew one times device certificate also, LTM device
Yes.
certificate. Logs and error message to the, this is the path where error message log slash var log GTM. File that appears similar to the following example. These types of error we get if device certificate get expired. SSL error, certificate where filled. This is the command to check the validity date of the certificate, device certificate. OpenSSL is the tool. 509 is the format of the certificate. Dash no out means we want output in not in encoded format. That text we need output in text format. This is the path slash config slash httpd slash conf
Yeah.
slash ssl dot crt slash server dot crt. If you run this command here, let me run here itself. Let me increase the size. If you run this command, open SSL, hit question mark. Okay, question mark not taking, we can hit tab here. So it will show some result here. 509, 509, 509. Or maybe we can hit X here and then question mark, or maybe tab.
Okay. So can we do like can we put one command over there like
Yeah, we can do that. Find.
find space forward
Mm-hmm,
slash
mm-hmm.
space hyphen name
A space,
hyphen name,
name.
yeah, space. Now our certificate name, if we have a certificate name. So in this way we get the details of the current certificate.
Okay, okay, let's see.
Yes. So yes,
Yeah, so see, this is
correct.
whatever you discussed. So this is the path where our device certificate is there. So now we can run this command, open
Open
SSL
everything. Yes.
X509. We are telling no out means not in encoded format. We need in that text format. Dash in means here we need to mention the path. We can simply mention this path, hit enter. So it will
Mm.
show the details of certificate. It is showing like not after September 6, 2026, not before September 6, 2025. So device certificate, uh, oh, okay, it is expired something because whatever date is showing, it is showing like validity not after September 6, 2026. So September is already gone, right?
Yeah.
So we
So
can,
this might be this is the trial one. So
yeah, correct. So we can renew it. So how we can renew
mm,
it? Simply we need to come here and You need to come here. Simply, you need to come here. Let me renew this. You come here, systems, certificate management, traffic, device certificate management, device certificate. But whatever command you told, this is also a useful command. Find, let me take some here. Find, yeah. See, so it is showing like version September 6. Let's try to renew it.
But it is going to expire on 2026. If you go back.
Oh, right. Okay. Cancel it, cancel it. Yeah. We were getting confused. We are in 2025. Yeah, you're
Um,
right. So it is going to expire not on September
yes.
6, 2026. So we are in 2025, right? So we are okay. That is the reason it is working. Otherwise, how we can
Yeah.
do other lab and access it, right? So this is the common things. Yeah. Good guys. Okay, so this is the first things we need to do while doing troubleshootings. Check the validity. Then second thing we're gonna TCP dump.
Hmm.
TCP dump you can check for the all the port for this port. So whatever communication happened between our 35 DNS to all the LTM boxes, it use the port number 435. So we can check the
Yeah.
status and everything. Let's run this in front of you. So TCP dump, you can copy the command TCP dump dash NNI. In one N means not resolve IP to FQDN, one N means not resolve port to the FQDN. And I use 0.0 almost all the port. X use for the X is basically kinds of format where display all the result dash X dash S means set 0. I don't know what is the meaning of 0 here, but let's show the result 0 port 4353. So we are saying everything, every details is here. Let me try to. We are able to see push packet here.
Yeah.
Like this push means our communications between our F5 DNS to LTM boxes 130, 131 is fine. Our LTM box is doing acknowledgement.
Yeah.
So this is the second beautiful command. So do troubleshootings in case of F5 DNS. Then the third command, do the same thing, but here we can specify the GTM listener IP, whatever we created. This is for the specific VLAN if you want to do that. This is to capture in pcap.cap file. And if you run this command, it is going to be captured on this interface with this file. And if you run this command, it is going to read that file in the CL itself. So let's try to do this. Let's try to do this. TCP dump dash NNI, and we can use 0.0 for all the interface. Port 53. Port 53.
Right.
And we can save it with the name management.cap. .cap. Okay. Capture size is happening 65535 bytes. Okay, let's do Control C. So 0 packet receive a filter, 0 packet draw by kernels. Okay, so there is no any packet capture in this time. We need to
P3 maybe initiate.
yeah. So what we can do, we can instead of 00, let's try to use here. Can use any here. Anyway, we can do, what we need to do. We need to maybe initiate some traffic from this box towards our LTM boxes. So if, for example, this is the capture, so we can read with the help of this. TCP dump R means we are
Yeah,
telling to read inside the
F5.
CLI dash R, and we can read this. See?
Yes.
So we can read this, and it is mentioned port and everything. Yeah, of course, it is not capture much packet here, so we are not seeing details much things here, but we can read, we can follow this command to do and read the capture things. These things, see, this command is very helpful. First one is check the device, and second one TCP dump whatever we have run. Two is very important, and last one is IQ dump. So on GSLB session, I have mentioned IQ dump. So IQ dump basically, if you run the IQ dump, you can check the establishment between our F5 DNS to LTM. Like there is connection between our F5 DNS to all the LTM boxes or not. So
Okay.
IQ dump. See if the IQ channel is established. IQ dump return XML similar to the following example. It is going to be mentioned here connected. So if you run the IQ query, like IQ dump and give the IP address of the LTM boxes, it is going to say connected. If it is not connected, means we need to check reachability. Where is the gap, routings and other stops in between our F5 DNS to the LTM boxes. If you are able to see connected means we have the reachability between our F5 DNS to the LTM boxes. Let's run that IQ dump, and we can give IP address 192.168.1.130. Means we have the reachability. So if not, then we need to troubleshoot. Okay, first try with the check like how is the traffic flow, how is the design, how many devices comes in between our F5 DNS to LTM. Accordingly, we need to check the hop by hop. Check the status of that LTM box. It is up, or it should be running properly or not. So it should be up and running. And then, if possible, try to log in manually to that device, check the VPA status and also check the interface status. So these are the basic things. If it is not getting result like connected.
Okay.
So these are things we need to do in F5 DNS troubleshootings. I will share all the PDF in the chat
Yeah,
so that
please.
we can refer it. You guys can refer it. So let me stop the recording.